something, okay, then you always say, I'll just unplug it. Or if we're in the teacher's workroom making copies and the copy machine will kind of lock up, they'll go, I'll just pull the power. And it always fixes the problem. So here's what you're going to do. How do you reset the memory? Okay, I'm going to show you how to do this. Tomorrow morning, you're going to go to first block, check in, and then you're going to come in here. And you're going to come in here and you're going to be calm. After eating a good protein-filled breakfast, no pancakes, honey buns, and powdered donuts, okay? Powdered sugar donuts. Don't do that. Don't do that to yourself. Don't do that to your brain. You're going to get you a good rest tonight, and you're going to eat you a good breakfast in the morning. And if you say, I don't typically eat breakfast, well, eat protein in the morning, okay? Now, here we go. How do you clear your memory? This may fix your problem. If you'll go to second plus, your menu may be a little bit different than mine, but it's basically the same. Go to set or go to reset, whatever your number might be. And we want to reset all RAM. So I'm going to hit 1. And then I want to reset. Second plus. Now this is what, now you're cleared, okay? Now, when I do this, this is what I cannot tell you tomorrow. And I'm going to have to rely on you guys to tell each other. After I clear the memory, everything that I have done to my calculator is now gone. What do I need to make sure that my calculator is in? What? It's got to be an A plus BI. How do we do that? We're going to do that right now. Mode. And just for kicks, because we're used to this, we usually want it in degree mode, right? Just for kicks. You're not going to have a problem that it has to be in degree, but we just usually typically have it in degree mode. And then we want to be able to put it into A plus BI mode. I cannot tell you that tomorrow. I have to read completely from the script. It's like, if you were to ask me a question, I will say to you, I cannot answer that question. Please read your screen again. And then you may say, I cannot answer your question. Please read your screen again. I may be crying right along with you, but that's what I'm going to say to you. What's the second thing you have to remember? Diagnostics need to be on. Okay, how do we get there? The catalog. So hit second 0. Y'all hit your D, or I'm just going to arrow down to D. Cut your diagnostic on. That's another thing I cannot tell you. Remember, that helps us find the correlation coefficient. If that R is close to 1, then you know you've got the right equation. We've talked about that briefly. Not for us. It would have mattered in geometry. It will matter in trig. For us, no. Okay? How do I declare it again? Tell me again real quickly. Second plus, reset, all RAM, reset. Oh my, what do I need to do now? Go to mode. I have to have, don't really need degree, but it's okay if you have it. And then what? A plus BI. Folks, we know for a fact that we have had students sitting taking the test. They are visibly like, what is going on? And they're working these types of problems with imaginary numbers, and they cannot figure out why they're not getting the right answer in their calculator. And it's because of what? Because it's not in the right mode. Okay? And I can't, and there's nothing we can do. I can't go, I can't do anything. I just can say, I'm sorry, please read your screen again. That's all I can say to you. Okay? And then what am I going to do after I put it in A plus BI, not BI, second catalog, diagnostics, cut those on. Right on? I better do that now. Now, where are you going to go first thing in the morning? And check in with first block, and then you're going to come where? You're going to come here. You're going to have plenty of pencils sharpened, right? You don't have to take anything in there with you. Then you're going to line up how? ABC order, alphabetical. Folks, if you're an A name, then you go here. And this is such a large class, and my first block's going to be in here. Then wind yourself along the wall. And please don't let me have to tell you that in the morning, okay? I would greatly appreciate somebody just taking charge and going, here we go, and do that for me, okay? You're going to be fine. You really are. I'm not worried about this at all. All right, let's talk about practice 2, answers. Here we go. Number 1, you should have A. Number 2 is F. Number 3 is D. Number 4 is F. Number 5 is C. Number 6 is G. Number 7 is A. There's not a typo on number 8. The answer is G. Had a brain moment. Number 9 is C. Number 10, H. Number 11 is B as in boy. Number 12 is J. Number 13, A. 14, G. 15, B as in boy. 16, F. 17, C. It's that multiplicity thing we talked about on Friday. Number 18, J. Number 19, B as in boy. 20, G. Number 21, C. 22, F. 23, C. 24, F. 25, B as in boy. 25B, yes sir. 26, H. 27A. 28, F. 29A. 30, F. Go to the next page, 31. 31 is D as in David. 32, J. 33, C. 34, G. 35, A. 36, H. 37, B as in boy. 38, H. 39, A. 40, H. 41, D as in David. 42, G. 43, C. 44, H. 45, B as in boy. 46, G. 47, A. 48, G. 49, D. 50 is F. 51 is C. 52, G. 53, B as in boy. 54, F. 55, B as in boy. 56, H. 57, A. 58, G. 59, D as in David. And then number 6 is H. Okay? All right, let's go to first page. Questions on the first page. Yes. Number 2? Yeah. All right, number 2. Assuming no denominator is 0, first thing I would do with this is factor. Factor everything possible, okay? So that top numerator can't do anything, or that bottom, well, the denominator is the bottom. First fraction we can't do anything with. Second one we can. So I'm going to rewrite all of this. And I'm going to factor out a 4x, which leaves me with 4x times the quantity x plus y over 6 times x plus y. And then remember, we can cross-cancel factors. So my x plus y's cancel. I can cancel 3 goes into 3 one time, 3 goes into 6 2 times, right? 2 goes into 2 once, 2 goes into 4 2 times. What else is going on here? What's going to happen with my 2's? Won't they cancel out? What's 2 divided by 2? 1. So they cancel out. And then I don't have anything else that I can cancel out. Okay? So now I'm going to multiply straight across. And I'm going to get x squared y times, let me rewrite it this way. X squared y over the quantity squared times x over 1. And now multiply across. And you get x cubed y over that quantity squared. Okay? Just factor and then cancel common factors. Can you cancel terms out of factors? No. You can't cancel terms out of quantities. Okay? Any other questions on the first page? Yep. Absolute values. It has to do with it being the fourth root. Just ignore them. No, don't worry about it. You still don't need to worry about it. You saw answers like that, and I told you the same thing. Don't worry about the absolute value symbols, okay? But it has to do with being the fourth root. Other questions on, thank you. Do you have questions on the first page? Yes. No. Okay, flip it over. Page, second page, 6 through 11. Any questions? Yes. Number 7. I love you. All righty. All right, here we go. All right, this is what you're looking at, right? And it's asking you which are its asymptotes. If you're given the graph, and it is clearly by the answers you're given, it's clearly asking you about horizontal and vertical. Folks, where could I draw a line where the line's going to approach it horizontally? And I had to draw it in there so I could draw the curve. Horizontally, it's going to be right here. And I actually darkened it in on my own paper, okay, which you can't see that very clearly. But what is this line right here? What is the name of that line? Y equals 3, okay? And then what's the other, or the vertical line that the curve approaches? Sorry, yeah, I just drew it wrong. Yeah, it is y equals 2. I thought it was 3. Dang. Okay. And if you draw your line in there, it is at 2. Yeah, I just looked at it wrong. So it's like this, and then like this. And I literally do that right there, okay? I just darken in, use your highlighter tool, okay? So that's going to be y equals 2. And then if it's the y-axis, what is that equation? X equals 0. So that's y. But seriously, your highlighter tool will be your best friend on this test. Okay? Any other questions? Does that help? Any other questions on that page? Going. Look at the next page. Any questions 12 through 16? Yes. Number 12. This is calculator. Okay? Rachel, do you mind? Go to your stat. Folks, I'm going to tell you what, if you can use your calculator backwards, forwards, turned upside down with a twist, you're going to be fine. I'm going to put in my lists, which are 5, 10, 15, 20, 25, and 30. Does everybody understand how to put these numbers in there? All right, then I'm going to put in the corresponding y values. 525, 506, 500, 506. Hey, do you notice anything about those y values? They start going back. Do you notice, just by looking at the value, the y values, that they, if you were to start at 500, Catherine, and looking at your, looking at this list of numbers, if you were to start at 500 in that y row and go back out this way, those numbers are symmetrical. Okay, now, what kind of function are the values, or what kind of function is symmetrical? A parabola, which is a quadratic. Now, keep that in mind, but look at this. I need to watch it. I need to see it graphed. Oh, it's not going to do anything. How do I see the graph? Tell me how to get there. Zoom 9 for stat. Oh, I still don't have anything. How do I get there? What do I have to cut on? My stat plot. They've got to be on. And I want to see my scatter plot. Folks, you've got to know how to do this. Now let's try to graph it. Still, second, y equals plot 1 has to be on. And once it is, then I want to graph it. Still nothing, so I'm going to hit zoom 9 again for zoom stat. All right, look at the curve. That's not there. What is it? It's a parabola. Now, I still want to make sure I'm thinking it's a quadratic, right? How can I verify that it's a quadratic? Remember, our diagnostics are on for a reason. If you go to stat, calc, we're thinking it's a quadratic, so go to quad reg. Folks, if your r squared is almost 1, what will be your correlation coefficient, r? Almost 1, wouldn't it? If I take the square root of 0.99999598966, right? And if you need to write this down, let's go here. Y equals 0.25x squared minus 9.9x plus 599.8, and then put that back into your y equals 0.25. This is the way I double check. Put in that equation and hit graph, and that parabola better go through there. And then you're going to know for sure that, heck yes, I've got the right answer. Questions? Catherine, does that help? Okay, good. Christian? Questions? You good? Any other questions on this page? Yes. Number 15. Let's look at that one. 5, 10, 20, 40, 80. It says consider the geometric sequence below, and it says which recursive formula could be used to find the nth term a sub n in the sequence. Well, if you look at this, this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. You guys agree with that? So just pick a value. Pick which one you want to work with first, okay? Let's say that we look at, I'm going to just use this one. If I were to use a sub 4, and I started looking at my options, so look at A. That means if I use option A's formula, a sub 4, then that's going to be equal to a sub 4 minus 1 times 1/2. Do you see that? Which is a sub 3 times 1/2. Folks, what's my third term in the geometric sequence given? My third term is 20. What's 20 times 1/2? 10. Is my fourth term 10? No, A is not my answer. I go to B, and I do the same thing. I still choose my fourth term. And I just randomly chose my fourth term, and you could have chosen your third. But now I'm going to use option B's formula. A sub 4 minus 1 times 2. All right, let's look at this. A sub 3 times 2. What is my third term? 20. What's 20 times 2? 40. Did it work out? Is my fourth term 40? Yes. Therefore, B is my answer. Does that make sense? Okay, yes. There. If you were to have any problem and it said, find the solution set of those two functions. How would you do that in the calculator? Wherever they intersect, folks. Do you know how to find the point of intersection on your calculator? Yes, everybody good with that. I'm going to tell you what, calculator's your best friend. How do you find? If the problem said, find the solution set of these two functions. How would you do that? Second, what is it, Quentin? Second calc. And then it says intersect. Christian, you good? That's all you have to do is find the points of intersection. Any questions 17 through 20? Thank you, Rachel. Yep. How do I do 18? Oh, this is one we talked about on Friday, okay? Did we have that same problem? Or one very much like it on Friday? It was a whole lot like it, wasn't it? You need to know that any function, when it's translated up, it would be, all right, hold that thought. Are you cool with finding the intersection? Are you sure? We are now. Okay, I'm going to do 17, then I'm going to do 18. 17, here we go. So your function, do I even need to put this in my calculator? Talk to me. How come? It says, what is true of the zeros of this function? Aha, we talked about this also on Friday. All right, the zeros are -2, 0, and 1. Do you guys agree? You can just tell that from your graph. But why is the answer the 0, 1 has a multiplicity of 2? What does that mean about this right here? Multiplicity of 2. What's that mean? It's because it's a double root, okay? That means that, and we talked about it on Friday, remember the problems like this, x squared plus 6x plus 9. If we had to graph that, before graphing, Isn't that factored correctly? X plus 3, X plus 3. How many, what are the zeros? -3 and -3, but can you have two zeros at -3? No, this is called a double root. And that's why this has a multiplicity of 2, meaning it's twice. There are two zeros at 1. Okay? Who asked that one? Christian? You asked about that one? That's what it has to do with, double roots. Okay? That's what it has to do with. Okay? Well, look at your options and just eliminate. That, if it had 2, if the 0, -2 had a multiplicity of 2, then it would either look like this, 1, 2. It would either hang from it or it would be sitting on top of. It would not pass through it one time. Okay? Any other questions? That was a good question. Because it says the 0, 1 has a multiplicity of 2. Multiplied by 2. It is a double root. Same thing Ted just asked. If -2, if the root -2 had a multiplicity of 2, Christian, then it would either look like this. It would either hang from that point, -2, or it would be sitting on top of that x equals -2. Okay? And that truly, you just have to eliminate and think. Probably not going to see that. I wouldn't spin your wheels on that. I wouldn't get hung up in that. Okay? Just remember, multiplicity has to do with sitting on top or hanging from. Number 18. Okay, here we go. If the option was F, and it said it was a vertical shift 2 units up, if the original function, and if you'll look at the problem, it's given f of x is equal to 2 raised to the x power. If there was a vertical shift of 2 up, vertical up 2, then this function would look like this. F of x is equal to 2 to the x plus 2. That's the way that, and if you're not certain about that, you ought to know that, because if we looked at this function, y equals x squared, and I said, tell me about x squared plus 2, what would that parabola be? What would happen to it? It would have shifted up 2 units. And you're going to put that in your calculator to verify it. Same thing with this right here. I need to see if this matches what I see in my graph for number 18. Same thing with F. Vertical shift of 4 units up. Vertical up 4. Well, then it better look like that right there. Correct? And it doesn't. When you graph it, it doesn't. Vertical shrink, now this is, so now I've narrowed it down to H and J. And when you put in, it says shrink by a factor of 1/4, then that would be 1/4 times 2 to the x. And when you put that in your calculator, you can tell it does not look like anything on here. And then go with 4 times 2 to the x. And you'll see that the picture matches what's on your paper. Okay? Does that help? All right. Other questions on this page? Yeah. Okay, stretching. All right, go. Next page. Any questions 21 through 25? Quickly. Yes. 21. A minus 2 over A over 1 over A squared. Some of you will do that bar thing, and that's okay. I have to go old school because this fraction bar means division. Okay? I'm going to rewrite A minus 2 over A divided by 1 over A squared. And then I'm going to multiply by the reciprocal. And simplify. Okay? And I'm going to keep going, and it's going to be A goes into A squared one time, or just A. And then A squared times A, I'm going to look at my options. Do I need to, FOIL or distribute? And I don't, because the answer is C. Okay? Cool with that? Cool with that, Catherine? Okay, yes or no? That's a reluctant yes. Okay.
If you were going to do the, like the FOIL thing.
That bracket.
Yeah.
How does he do this?
He goes the top one and the bottom one together, and then the two middle.
That right there?
Yep. If you were to set it up, that's how you would like. That's the way I've always been doing that.
Oh, how does he do this?
See, if you were to multiply
Do you multiply the top to that? Okay, so then you have this over A. Oh, the A still cancel. Okay, yeah, okay. Y'all have to always talk me through that because my brain just does not get it. Okay. I'm all right with old school. Thank you. Any other questions on this page? 22? Putting that number in exponential. That means we have to use exponents. Okay, we're not just simplifying. What is the exponent of 81 right now? It's there but not there. 1. What's the exponent of z right now the way it's written? 1. It's there but not there. And remember that your index is always going to be in the what? Denominator. Why? Because it's sitting at the door of the house. Denominator. So we're going to rewrite 81 to the 1 over 3, the exponent over the index, z to the exponent over the index. And then look at it. What? There's nothing there. That looks like 81 to the 1/3 power. What are you going to do? Put it in your calculator. You're going to put it in your calculator. All right, Rachel, I think you're going to have to do it. Yep. Watch what you do. Because I get to this point and I go, for real, seriously? I know that what's not going to be an answer. I know z to the 1/3 is correct. So h is not an option, okay? So look at F. 3, oh, fart, balls. Excuse me. That was recorded. Yes. 3 raised to the 4/3 power. First of all, let's figure out what 81 raised to the 1/3 power is. I think, oh, yuck, vomit, right? Now go 3 raised to the 4/3 power. Because I want 3 to the 4/3 power to match what? The one above it, that 4.32, blah, blah, blah. Oh, look. It worked out. And then go back through and see what 3 to the 3/4 power is. You know it can't be j. You know that's not right. Okay? Cool with that? Yes or no? Okay. You could have. Because your brain thinks that way. My brain didn't think that way. My brain said figure out what it's equal to and then see if 3 to the 4/3 is also equivalent to the same number. Totally fine. Any other questions on this page? 24. What are the solutions? Here's a clue, folks. When you are finding solutions and all of your options look like x is equal to something plus or minus, and then it has some type of radical. I know it's ugly. Don't make fun. What is that a clue, maybe, that you're going to have to use? Quadratic formula, okay? Now, the first thing you have to look at, though, is look and see if this quadratic plus 9 equals 7. First of all, can I solve it the way it is? No, what do I have to do? I have to subtract 7 because I want this thing equal to 0, yes? Now look at that. Can it be factored? No. That's clue number 2 that I have to use the quadratic formula, okay? X is equal to negative b plus or minus square root of b squared minus 4ac, all of it over 2a. Is that on your formula sheet? I think it is. Yes, it's on your formula sheet. Boom, right there. So you do not have to memorize it. What is A? What is A? 1. What is B? And C? Do I need to work through this? Do I need to work through this? Sure? Okay. Other questions? Flip the page. 26 through 30. 27. Let's look at 27. Let's look at 26 first. Okay. Then we'll do 27. There are 18 students on the student council. 18 students. If 5 of those are chosen to be on a committee, how many different 5-student committees are possible? My number one question, does order matter? No. Order does not matter. So is this a permutation or a combination? If order does not matter, combination. That's exact, yeah. And then I say this. Remember, this is a calculator problem. I go from 18, and then Mr. Gammons, and I never heard it this way, from 18 choose 5. And that was the same wording that's in the problem. Chosen to be on the committee. From 18 choose 5. And this is all calculator. Please be on. Yes. Remember where that is? Math. All right, first thing we have to put in is what, though? 18, math, go all the way to probability, and then which option? 3. And now put in 5. Hallelujah. If it said something like we had to figure out the president of the, or the committee chairperson, then order would matter. If you had to have a chairperson and a secretary, then it would matter. It would state it, and that's how you would determine between permutations and combinations. Here's the way I have to think of it. This is so, y'all know I'm, do y'all remember, I think it's come back, the brand of clothing, Ocean Pacific. Do y'all, is that out now? Maybe at Walmart or something, I don't know. That used to be the stuff back in the day. But this is how I remember it. Order matters in permutations. And if it's not an order matters, then it has to be a combination. I know that's dumb, but that's how I have to remember it. OP. That's how I remember it. It's a combination because order does not matter. When order matters, it's permutation. When order does not matter, stop talking, it's a combination. Okay? And the video is on the homework page. You can watch that. Okay? Or not. Other questions? 27. Let's look at 27. It says, given that x is greater than or equal to 0, f of x is 4x squared, and g of x is root x over 2. Are the two functions inverses? How do we determine if they are inverses or not? Pardon me? Both of them have to equal x. We have to find f of g of x, and then we have to find g of f of x. And when I have that composition of functions, then both of those better equal 0, better equal x. Here we go. I'm going to take the g function, and I'm going to put it in place of x. So that's going to give me 4 times root x over 2, that whole thing squared. And I'm going to make this, I got to clean this up for me. 4 over 1. Folks, what happens when I square a square root? It becomes that value. So it just becomes plain old x. And then don't forget, 2 squared is 4. What happens? 4's cancel. Heck yes, it's equal to x. I'm halfway there, okay? Now I have to do the same thing over here. And now I'm going to take the f function, and I'm going to put it underneath that radical. This is kind of weird. So I have square root of 4x squared over 2. You with me? Okay. What is the square root of 4x squared? 2x. Heck yes. They're both equal to x. What does that mean? They are inverses of each other. Yay. Hallelujah. Yes. Other questions? 30? We good on this one? $29. All right. We want our denominators the like denominators to be together. So I'm going to take this thing and I'm going to move it over here. That's going to give me x over 5 is equal to 1 over x minus 1 minus x over that mess. Now, what am I trying to accomplish? I'm trying to get this into a proportion. Because these are like denominators, I can write this as 1 fraction. And then I'm going to cross multiply. We did this. Because this is what Mr. Gammons was like, look at this. And I was like, oh. Because this is a forest problem. Okay? Cross multiply and solve. X squared minus x is equal to 5 minus 5x. Do I need to continue? All right, here we go. I'm going to add 5x. And I'm going to subtract 5. I'm trying to set everything equal to 0. Okay? And then, I hope this said find the solutions. Yep. What value of x? All right, so give me 2 factors of 5 that when you subtract give you 4. 5 and 1 plus 5 minus 1. That means my solutions are -5 or +1. Right on? Okay? That's okay. Guys, I'm going to put my work on my homework page. If I do it from home, it is such a big file, it'll never load. But if I run it here and scan it, it works fine. So I'm going to post all of this to my homework page. Okay? Just FYI. Number 30. Let's look at 30. Below is the graph. F of x is equal to the natural log of x plus 6, which is the equation of an asymptote of the function. All right, here's the picture. If I can do this. 1, 2, 3. All right, it looks something like this. Now, if you look at this, it is very clear that it approaches that y equals 3, okay? It looks clear, but it's kind of cut off there because like your window stops right there and you're not sure what it does up here. But when you look, the function acts like it's sitting right on that x equals -6. It looks like it is. Now, I look at it, when I looked at this problem, I went, so does that mean my asymptote is x equals -6, or could it be y equals 3? And I wasn't sure. So I went to, and this is so, I've got all this written out. Go to your calculator. Please be on. You may just want to sit at my desk. I'm sorry. Thank you. Because I wasn't sure what to do. So I looked at the graph. And I put in the natural log of x plus 6. This will be beneficial to pay attention. Nope, the natural log. It's right up underneath the log. Now, I don't know if your picture looks like this. But do you see how there's nothing here at the bottom? Okay. Now it's when I know. An asymptote is a place where the curve approaches but never crosses, correct? So I went to the table and I said, all right, it's either got to be y equals 3 or it's going to be x equals -6. I know it has to be one of those two. So I looked at the table. And I just started looking at the values. I went back to x equals -6, and look what happens. What does that tell me? It tells me there's an error at -6. So that means that my asymptote is there because when I go to y equals 3, watch what happens. Look at y getting bigger. If 3 is an asymptote, if it's a horizontal, then this curve should not cross or go past 3. Do you agree with me? But look, all snap, it just did. So what's the asymptote? What's the best answer? -6. This is my thinking. Might not make any sense to you, but that's how I approach the problem. Pardon me? No, because that's where the curve doesn't, there's nothing going on there. It just stopped, yeah. And it had to do with it being a natural log, and that's just weird. All right, real quickly, questions on 31 through 36? Other one? 35? 35, it says the number of bags of seeds B that a farmer needs varies jointly. That's what I would highlight on my test. I know joint variation is like y equals kxz. That means something smashed together, okay? But I have to put words to it. So I kept reading. As the number of acres, it says the number of bags of seeds varies jointly as the number of acres that will be planted and the number of pounds of seeds. And I have to write that out on my paper, because I will forget where to put my numbers. I won't remember what the variables mean. It says the farmer would need 750 bags of seeds and used, if he planted 500 acres of land and used 50 pounds of seeds. So then you get 25,000, okay, divide by 25,000. And then I didn't even have to solve for anything because it just asked me for the constant of proportionality, which is 750 divided by 25,000 is 0.03. And that's all you do. Okay? Other questions on this page? Hey, look at number 31. I don't think so. No. No, ma'am. Those won't be there. Hey, look at number 31. The functions are graphed. What's the solution? How could you very easily find the solution? Where they intersect. It's very simple. Same thing with 32, folks. Put those in your calculators, graph them, find the points of intersection. Easy. Holy crap, easy. 37, 38? 38. Let's look at this one. Please be on. Yes. All right, we got to go back to our list. So go to Stats, Edit. Do we ever delete our lists? Do we ever delete our lists? No, never ever, because then you're going to freak out. And that would not be good. Clear your list. Here we go. 2, 4, 6, 8, 10. Put in the corresponding Y values. 90, 270, 800, 2400, 7200. Graph. Y. Got to cut my plots on. I'm going to clear that out of there. Graph it. Oh, I still don't see anything. What shall I do? Zoom stat. Zoom 9. Aha. Now, it says in the research experiment, the number of fruit flies is increasing as shown below. Obviously. These data are best modeled by what? An exponential function. Folks, it's no guesswork. It tells you what kind of function it is. It says, which is the best estimate of the number of fruit flies there were 7 days after the research began? Courtney told me she did something kind of cool, which I never thought of. She moved her cursor to 7. She just moved her cursor closer and closer to 7, where it would be. And then did you try to put it in line with the curve? So she just went down. And she went, oh, look. A little bit lower. Do you see what she did? Now, that's just being a fart face. That's very clever, calculator ninja. All right? Because look at her Y value, which is approximately 1493. Folks, what's closest to that answer? 1390. Now, here's what I did. I'm told it's an exponential function. So go to Stat, Calc, go all the way to option 0, exponential regression. Oh. But this is totally doable. Look at this mess. And it ought to be on your calculator too, because I know you're following right along. This is showing me that it's going to be y equals 30.11 times 1.729 raised to the x power. Do you see that? Okay. X has to be 7. So I'm going to put 7 in here for x. So I'm going to go 30.11201. I don't care how many numbers you put in there, times 1.728826. The more numbers you put in, the more accurate your answer will be. And I'm going to raise it to the what power? 7th power. I'll be John Brown. Look at there. Pardon me? It told you in the problem. told you in the problem. Okay? No, we're on number 38. We're on number 38. Are we cool? Other questions? Okay. Look at page 30, or numbers 39 through 43. Questions on that? '41 flipped me out when I looked at it, but it's just an application problem. Says a car skids to a stop on a race course. The formula S is equal to root 21D relates speed of the car to D, the length and feet of the skid. If the car is traveling at 105 miles per hour before it begins to skid, what will be the length of the skid marks? 105 miles. Where am I going to put 105 miles? Where am I going to put 105? In for S. And then what's it asked for? What will be the length of the skid marks? I have to solve for D. This is just an application of solving an equation. How am I going to solve that for D? I have to isolate the variable, but how do I get the D out from underneath the square root? Square it. What you do to one side, you have to do to the other, and it gives you a ginormous number, 11,025. Not that big. It's not that big. Divide by 21, and D is 525. That's all. Kind of flipped me out when I looked at it, but I went, oh, it's really easy. It's not difficult. Just an application problem. Other problems, other questions on this page? 42, sum of cubes, folks. You better know that. Better know it. Pardon me? Yeah, you just literally use that formula and plug in the values. Exactly. 45. Okay. 45, let's look at that one. R of x is root 2 over x, or 2x. S of x is x plus 9. And we've got to find R of S of x. What am I putting into what? Put S into R, okay? Put S into the R function. Watch what I do. Root 2 times x plus 9. And then distribute. 2x plus 18. And that's it. That's all it is. Okay? And if this will help you, write it. Put S into R. Put this into this function. Okay? Work from the inside out. Okay? Yes?
Why is it greater than or equal to?
Somebody answer that for me. Why is it greater than or equal to, what was it, -9? Why, Sarah? So I won't get a negative underneath the radical. And then I'm into the imaginary set of numbers. Well, it would give you, which would just be 0. It has to be greater than or equal to 9. Okay, so think. If it were, pardon? No, we can take the square root of 0. We can take the square root of 0. Okay? Okay. That's all right. Other questions on that page? Going. Here we go, 47 through 49, questions. Folks, look, it's 47. How do you know which one's the inverse? It has to be reflected about what? The parent graph. It has to be a perfectly symmetrical, beautiful something. Like A. Yep. Oh, 46 is just like number, yeah, that is really. 46 is like 18. Put it in your calculator. Put it in a calculator and see which one matches. Okay? Yes?
That one,
For 46? Okay.
For the 2, like for the y-intercept, we have to find the answer choice that has the y-intercept 2.
Say what?
The CT and age,
Yes.
which knows the most probable answers because of the y-intercept being 2.
Yes. If you were eliminating. Yeah, absolutely. Absolutely. But then put it in your calculator. Yeah, you were right. Yeah. All right, no questions on that page? 47 through 49. We've already talked about that. 49. Oh, let's see here. It says a piece of equipment's made of 6 parts that can be assembled in any order. In how many different orders can the piece of equipment be assembled? If I were to take 6 of you and I were to line you up at the door, we want to see how many different ways we can line those 6 people up. How do we figure that out? Mathematically, do what? Okay. Or, this is just 6 factorial. Okay? If you remember from the video we watched, that's all you do. Now, I don't want to have to do that. Put that mess in your calculator. I mean, that's easy, but put it in your calculator. Rachel, I'm going to buy you a cookie. Thank you. Yeah, but, yeah. Okay. 6 factorial. 6, math. Go to probability. Go down to option 4 for the factorial. Because what if it said, here are 100 people. Put them in any order. I don't want to go 100 times 99 times 98 times 97 times 96. First of all, it won't work in your calculators because the number's going to be so big your calculator can't compute, okay? But you can do that. Does that help on that one? Remember, I'm going to put all of my work on the, Any questions real quick on the last 2 pages? 50. Let's talk about 50. Why can the answer not be H? Because you can have -2 seconds. So it has to be F. Was that what your question was about? Or you would put 0. It says that, stop talking. Well, I know that if the function is equal to 0, then I can find the solutions. Okay? And then I just factor. Let's see, what did I pull out? I pull out a -16, which left me with t squared minus 4. And then I set each factor equal to 0. That's not possible. T squared minus 4 is t minus 2, t plus 2. And I go, oh, my solutions are -2 and 2. But it's a word problem. And t represents seconds. Have you ever counted anything -2 seconds? Nope. Okay, good. Hey, how do you find the solutions of 53? Points of intersection. Other questions on that page? Calculator or FOIL it out. Okay? 58? Old school. Huh? That means you... Huh? Did she say your grandma did this problem?
No, I asked her for help because she got the same answer I did when she worked it out. It didn't feel like we got Hennessy on the bottom and on the top.
Your granny can work this problem?
No, she's a math teacher.
Oh, holy crap. I'm thinking my little great-granny, well, she's not my great-granny. She's my granny. She's my children. Little great-granny June would go, now you know. Bless her little heart. God love her. Old school. Old school. I love old school. Okay. Now, folks, treat this as two separate problems. I have to have common denominators, which will be 3 on this side. What did I multiply to this denominator? 3. What has to be multiplied to the top? 3. What's 3 times 3? 9. Remember? 3, 3, 9 over 3. Hallelujah. Same thing here. What's my common denominator? 9. Multiply 9 to the bottom, multiply 9 to the top. What's 9 times C? 9C. Here we go. I want to write this as one fraction. My grandma got this problem. Here we go. 9C plus C is 10C. And then multiply by the reciprocal. Three goes into 3 one time. 3 goes into 9 3 times. 9 plus C times 3 over 10C. I learn something new every day. Your grandma must be young. But I'm not. See, I think I'm y'all's age. I know I'm not. I know I'm not. But in my heart, I am. Yes, sir. Sorry. Is that good? Other questions? Oh, distributed normally. Okay? Here we go. The gymnasts. The gymnast is a 64-inch mean. The standard deviation is 2.5. So one standard deviation is 66.5. 2 is 69. 3 is 71.5. Going backwards, we get 61.5. Negative 2 standard deviation is 59. Negative 3 is 56.5. And it says 65%. Where is this? What percentage of players on each team have heights of less than 65 inches? Less than 65, which would be about here and this way. Do you agree? Now that's for the gymnasts. Now look at the basketball. Ugly curve. Here we go. Mean for the basketball is 68, standard deviation of 3. So 71, 74, 77, and going backwards 65, 62, 59. If my 65 doesn't land where a standard deviation occurs, then what does that mean, folks? What am I going to have to go to? Z-scores, okay? All right, before you do that, hold that thought because 65 occurs here. Hallelujah. What are my numbers? What are my percentages? 68, 95, 99, right? All right, and that's when I start breaking it down. So that means that from here this way, so that's going to be 34. What's that next little piece? 13.5? And then 2 and then 0.5. So what do? I add. You ready for this? 13.5 plus 2 plus 0.5. And I get 16%. And if you look at your options, Christian, it says 15.9% of basketball players. And that was the one I chose. I know that's right. And then I didn't have to figure out the 65% of gymnasts. You will have Z-score sheets provided for you, yes. It's a big old folder type thing, and you'll get all of that when we get in there. Folks, be patient. You know how usually we have always given you the paper? Stop talking. So I would take for the Z-score 65 minus my mean, which is 64. Standard deviation of 2.5. And remember, put that in parentheses, and I have no idea what it would be.
Whatever, 2.5.
Yeah. but I don't know what that decimal's going to be. And then you take that decimal and you find it on the z-score table, okay? And that would be the percentage under the curve less than that amount, okay? Yes, ma'am. As soon as I give you your paper, you can dump your information on your paper, yes. No, no. And if that changes,